times, well, n minus r factorial, which is kind of silly here because that's going to work out to the same thing as before. It just looks a little backwards, but it's the same thing. And then we get a to the r and b to the n minus r, where a and b are just the first and the second terms here. So here we want to find the term that's going to contain x to the fifth power from this special expansion. So we're looking for really this 2x to be raised to that fifth power. Okay, so that makes our r 5. All right. Our a is 2x, and our b is going to be y in this case, and n is this number right here, our 20. All right, so let's fill in what we can here from the formula. So we have n, so that's 20, over 20 minus r, so 25 minus 5. And then we have a to the r power, so that's 2x to the r power, which is 5. And we have b, which is y, to the 20 minus 5. Okay. So really that's going to give us 20, and then we get 15 here. And that's, let's see, 2 to the fifth power, 2, 4, 8, 16, 32. X to the fifth, y to the 15th. Okay. Now we just need to work out that 20, 15. So we have 20 factorial over n minus r, so 5 factorial times 15 factorial. Okay, so we have 20, 18, 17, 16, and then 15 all the way down. This will be 5, 4, 3, 2, 1. Whoops, 4, 3, 2, 1 times 15 all the way down. The 15 all the way down is going to cancel. All right, so when we work that out, that's going to give us, oh, that's a big number, 4, 9, 6, 1, 2, 8, and then we have x to the fifth, y to the 15th. All right. Here, let's find the term containing y to the third power. So again, this is my a, this is my b, this is my n, and we want y to the third power. Okay. So it doesn't really matter which term is considered your first term here or your second term. That's kind of up to you. But we could we could switch these around if that's any easier. It really doesn't make a difference. We could also just say in this case that n minus r is going to equal 3. I mean, there's nothing wrong with doing that. Really makes no difference. We could plug in to get r, so 12 minus r is 3. So that means that r is going to equal 9. Okay, so we want to figure this out. Let's use our formula. So we have 12 on top. We have 12, or n minus r, so that's 3 on the bottom. And let's see, a is root 2. We said that's going to be to the r power, so that's 9. And then we have y to the third power. Okay. So that 12(3) we've got going on is 12 factorial over 9 factorial and 3 factorial. Okay, so 12, 11, 10, 9 all the way down. Here we have 9 all the way down times 3, 2, 1. All right, so the 9s are going to cancel. That gives us 12 times 11 times 10 over 3 times 2 times 1. And that's going to give us 220. Okay, so we get 220 as our number out here. And we can think of this 2 as being 2 to the 1/2 power if that's easier. So that's going to give us 2 to the 9/2 power, y cubed. All right. Okay. And we could probably clean this up a little bit more, but this is basically the idea here. All right, last couple, we want to find the 24th term in this expansion. So we have a plus b to the 25th power, the 24th term, though. So if it is the 25th power, we really are going to have a bunch of different terms here. Our first term is going to be a to the 25th. Our second would be a to the 24th, 23rd, and so on. But remember, we actually are going to have 26 terms, right? we need to have a to the 25th all the way down to a to the 0 power. That makes this a little bit trickier. So in order to figure this out, what we really want to do is think about which term we're talking about, whether we're worried about A or worried about B, because problems like these were a little bit easier to deal with. So maybe let's talk about B. We would start with B to the 0. B to the first is actually the second one. B to the second is actually the third one, and so on. So to get the 24th term, we're actually just going to go back a number. That should be B to the 23rd. That should be the 24th term. B to the 24th, and then we'll end with B to the 25th. Okay? But remember, we started at 0. So the 24th term is actually where B is to the 23rd power. That then is going to mean that A is to the, let's see, this is 0, A to the first. A should be squared there. So that might be a little bit easier to think of. All right, so we have A, we have B. A and B are just A and B, but N is 25, and our R in this case is going to be 2. So we have 25. We have 25 minus 2, so that's going to be 23. And we have A to the R and B to the N minus R, so 23rd. All right, 25 factorial over 23 factorial, the difference is 2. That is going to give us 25 times 24 times 23 factorial, 23 factorial times 2 times 1, and the 23s are going to cancel. So let's see, 25 times 24 divided by 2 times 1 is going to give us 300 for the coefficient. All right, and then find the fifth term in this expansion. Remember, just tag these guys together. So AB, my A in this case is really AB. My B in this case is really -1. We want to find the fifth. So whichever way you want to do this, AB would be to the 0, AB to the first, AB to the second, AB to the third, 1, 2, 3, 4. The fifth term would be AB to the 4th power. So our R is going to be 4, and that means that our N is going to be this 20 out here. All right, so we have 20. We have 20 minus 4. We have AB getting raised to the 4th power, and then we have -1 being raised to the difference there, which is going to be 16. All right, so we have 20 factorial over 16 factorial times 4 factorial. 20, 19, 18, 17, 16 all the way down, 16 all the way down here, 4 factorial. So the 16s are going to cancel. 4 is really 3, 2, 1. Oops, 2, 1. So when we multiply this out, 20 times 19 times 18 times 17 is going to get divided by 4 times 3 times 2 times 1. So that's 4,845. This is a +1, and that's A to the 4th, B to the 4th,